Lesson 60, area of a parallelogram. Looking at the picture, figuring out how do we find the area of a parallelogram. Well, you can see in the shape right here that a parallelogram has two sets of parallel lines. But if you divide that into different smaller pieces, you can see that we have one triangle here. And if you go straight down here, there's a triangle. So if you move this piece over here, you would have a rectangle. And so an area of a rectangle is length times width or base times height. So the area of a parallelogram would be base times the height. We're going to use that formula to find area of different parallelograms. First one, find the perimeter and area of this parallelogram. Remember perimeter, just adding up all the sides. So to figure that out, we have this bottom piece is 8. If this bottom piece is 8, this top piece is also going to be 8. So we have 8 plus 8. This side piece is 6. That means this other side is going to be 6. So if we add them all up together, 16 plus 12 would give us 28. And this would be 28 centimeters. So this will be our perimeter. Now to find the area, it's going to be their base times our height. The base is always this bottom piece, so this is going to be 8. Our height. The height is going to be our vertical line, or our perpendicular line here, so it would be 5. Don't take the one that has the slant on it, because that's not the height. So it would be 5 times 8, which will give us 40 square centimeters. Problem 2, what is the area of this parallelogram? So finding the area. Again, area of a parallelogram is base times the height. Our base is going to be 7. And then our height, here you got to look at from the top to the bottom, which would be this dotted line here. So that is 8. 7 times 8 gives us 56. So this would be 56 square inches. So the one thing to remember is for the height, it's got to be a straight or a perpendicular line to the base. It can never be a slant. Next problem, the sides of a square and another rhombus are 3 centimeters long. Find the perimeter and area of each parallelogram. So let's find the perimeter of each of these parallelograms. So this is the square. The perimeter, I have 4 equal sides and they're each 3, so that's going to be 12. So 12 centimeters. I could just done 3 plus 3 plus 3 plus 3. The shorter way would have been just doing the 4 times 3. And then the area of a square, just taking the side and squaring it, so that would give us 9 square centimeters. For this rhombus here, find the perimeter. If all the sides are 3, that means this is 3, this would have to be 3, this would be 3, this would be 3. So here we would have a perimeter of 12, because you would have four groups of 3. And then to find the area, so this is 12 centimeters, take the base times the height, the base being 3, the height being 2. 3 times 2 is 6, so 6 square centimeters. Next one, we're going to sketch a parallelogram on a coordinate plane and then find the area. So it says sketch the parallelogram on a coordinate plane with the following vertices. So I'm going to plot these. So 2, 1, 1, negative 1, -2, -1, and then -1, 1. And if I just attach them, you can see I have a parallelogram, so we need to find the area of that. So to find the area, all we're going to do is find the base. So this is 1, 2, 3. And then the height, 1, 2. So the height is 2. So we have 3 times 2, which will give us 6. And we would just say this is square units. The second part says graph the dilation with the scale factor of 3 and what is the area of the image. So dilation means it's bigger. If it's a scale factor of 3, I take each coordinate and multiply each part by 3. So for A, 2, 1, I multiply both numbers by 3. So 3 times 2 is 6. So that would be at 6 and up 3. So that's our A. And then B would be 1, -1. So that would be 3, -3. So 3, -3 would be here. And then we have -2, -1. So -6, -3. Then I have -1, 1, so -3, 3, so -3, 3. And then I can draw my lines. There's my dilated parallelogram. Find the area. To do that, we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Base is 9. The height, 1, 2, 3, 4, 5, 6. We have 9 times 6, which would give us 54 square units. The area of the image is how many times the area of the parallelogram. So in order to figure that out, we could easily take the two areas and divide it. So 54 divided by 6, which will give us 9. So it's 9 times. Or you can take the scale factor of 3, square it, and that will give you how many times larger the image is of the original parallelogram, which is 9. Next one, find the area of a parallelogram with vertices at 4, 2. So 4, 2, -2, or 2, -2, -2, -2, and 0, 2. Draw our lines. Our parallelogram. We need to find the area. So it goes 1, 2, 3, 4. So the base is 4. The height, 1, 2, 3, 4. Height of 4. 4 times 4 is 16. So 16 square units. What would be the area of the dilation of this parallelogram with a scale factor of 3? So if I were to take the scale factor of 3, square it, be 9, so it's 9 times larger. Then I can take my 16, multiply it by 9. 6 times 9 is 54. 9 times 1 is 9, plus 5 is 14. So 144 square units. And our final problems. A brass sculpture of the letter N is formed from one long metal parallelogram folded into 3 congruent parallelograms. What is the area of one of the smaller parallelograms? So we're just looking at one smaller piece. We're going to look at this one. We have a base of 4, and then the height. The height they're saying is 6. So 4 times 6, which gives us 24 square feet. What is the area? What is the total area of the long metal parallelogram? So if this one is 24, we're going to use that. And since we have 3 congruent parallelograms, so that means they're all the same, the dimensions are the same, I can take my area of one of them, multiply by 3, and get the area of the whole thing. So it'd be 72 square feet. So that is our lesson today on finding area of a parallelogram.